Hello, RubyConfBY. I'm very glad to be here and very glad to be presenting a better kind of conscious coding practice. Through the magic of pre-recorded video, you're going to see me here, but I'll also be around in the chat and QA, and generally I'll be present at the conference, but right now you're getting me pre-recorded. Who am I? My name's Noah Gibbs. I've been doing this kind of thing a long time. I'm reasonably well known in the Ruby community. I could brag about myself for a while, but the thing is, you should try these techniques. Don't worry about the fact that it's me telling you to do it. If you have to worry about me, I'm doing it wrong. Let's talk about you. You're the important part of this. You want to get better at Ruby faster. You hunger to get better. Now, when I say you want to get better at coding, I don't mean algorithm design, I don't mean carefully working on a team, I don't mean becoming a very professional developer, in the sense of making your manager happy. I mean that you want to get better at the practical skill of turning an idea in your head into code. Now, there's a decent chance that you're worried about the computer science stuff. That's a phrase I've heard a lot of people use, from boot campers and new grads to much more experienced folks. They believe their problem is the computer science stuff. So, here's the thing. Everybody's worried about that, and you keep meeting competent programmers who are also terrified that they're bad at the computer science stuff. So maybe that's not the problem. Coding is practical. It's a practical discipline. You get better at it by practicing, not by reading about it. The practice is vital. You can't do without it. You can learn the algorithm, you can memorize all the language idioms, you can have a full requirements document with everything you need, and you can still stare into your IDE, unable to write that for loop, for an hour. You need practice, and good practice is better than bad practice. There's a whole mindful practice thing. There are books about it. I've written articles about it. But getting paid to code doesn't get you the best practice. This is part of the reason for those heartwarming arguments that you have with your team about what technology to use or how to do a particular thing. You are trying to code in a way that makes you better faster, which is why businesses like to promise interesting problems. There's always a tug-of-war between the boring stuff that makes the business money and what you want to do, which will make you better faster. You, when you're practicing on your own, can just do the stuff that makes you better as fast as possible. Good practice is better than bad practice. You don't need more algorithms to memorize. You need to be able to comfortably pick up and solve a new problem the first time that you see it. This fingertip feel comes from practice. Lots of the right kind of practice. The best programmers you've met don't do it by academic study, though some of them are good academics. They work on practical problems until they're comfortable with them. So can you. Now, it sounds like I'm going to recommend coding exercises to you, and coding exercises are fine. But somebody experienced has to write them for you. They don't usually exercise your judgment about what it is that you're building, and that is nearly the whole job that we do. It's hard to learn a thing you don't already know from a coding study. A really well-designed one may be able to teach you a genuinely new skill, but mostly they can't. Mostly they're not good at that. And of course you've got to find new ones, constantly. Also, you need to find new good ones, which means that the experienced coder has to also be an experienced teacher, and there aren't many of those. That's a hard combination. Let me give you a better choice that I call the coding study. You'll find variations on this done by a lot of old programmers. It's how a lot of us learn. It's how a lot of us do what we do. And it turns out that this same idea is used in a number of other professions, but especially one profession, and I'll tell you where I stole it later. But it's really good. Before you start, you pick a tool, you pick a task, you pick a purpose. I'll tell you exactly what I mean by those things, and you pick an amount of time, a time box, and you write them down. Doesn't have to be on paper, it can be electronically, but you write them down in words first. You do it yourself. You can also pair on it, but you don't need someone to administer this to you. You can just do it for yourself. And it's good from the time you can put a for loop together until at least 20, 30 years into your programming career. Maybe at some point it stops being good, but it lasts at least that long. So, told you how to do those things. How do you do it? You choose and write down these things. You work until you're done, or until the time limit runs out. Either way, you stop, and then you look back on what went well or what went poorly. You expected something like this when you came to a talk on practice, right? You expected something like this. Part one, of course, choosing the tool, task, and purpose, is going to be the trickiest, and so we'll talk a fair bit about how to do that. So let's make it very clear what I mean. Tool. You understand what I mean by tools. It can be language, it can be libraries, it can be both. You're already pretty good at tools, but I mean the things you're using to build this piece of code. The task is what you build. That's what most coding exercises will give you. Maybe they give you a little math or an algorithms problem, but what you're building could be that. And the purpose, this is the thing that's unusual here, is why you're building it. It's what you want to learn. The best exercises already give you this, but most of them don't. If you're picking up a new algorithm to learn recursion, then learning recursion is your purpose. It's not what you're building, but it is your purpose in building it. If you're picking up a new Ruby file attachment library to learn about file attachments at the HTTP level and how they work, learning about file attachments at the HTTP level is what you're doing at that moment. It's your purpose. If you write a giant chunk of code with no if statements and just use every other conditional construct your language gives, then your purpose was to learn about alternatives to the if statement. Your purpose is why you're building. You're already good at choosing tools. You are already good at choosing tools. You have a favorite set that you already use, and that's great. Keep doing that. And every so often you'll pick up new ones, and your purpose then is to learn the new one. You don't need a different purpose. Your purpose then is to use the new tool. You're good at that. Keep doing it. Choosing the tool is the easy part. There are two ways to choose the task. One is simple and you're already good at it. The other is interesting, and it will make you better faster. I'll tell you about both. The easy way is exactly what you already do. Choose a little thing to do. Just pick it. Maybe you're going to write a little music organizer that sorts your files according to tags that are in the file name into playlists. Maybe you're going to do a little math or an algorithms problem that you found online on a coding challenge site. You can find some tiny little task, and there are lists of tasks, right? There are lists of go off and do a coding project. You have lots of them. It's fine. You could do something silly like write a little ASCII program that prints stuff on the console. There's all kinds of little cute things you can do. This is fine. This is what you already know how to do, and it works okay. The interesting way to choose a task, the way I'm going to recommend you choose a task, you can do the other one, but the best way to do it is to look at the world, to pick something, anything in the world, and turn that into a system of behavior. It turns out you already know how to do this because that's most of what a job in coding is. But literally every piece of the world around you is so complicated that you could observe forever, and any one piece of those, you could observe it for a lifetime and never get done. So there's no shortage of interesting stuff. We'll have an example, because I know that's tough. And then let's talk about how to choose your purpose. If you have a purpose already, don't let me talk you out of it. You do what you're doing. But in case you don't have one already in mind, let me tell you 3 excellent methods that can help you choose a purpose. Method 1. What superpower do you wish you had? What's something you want to be able to do? Have you seen somebody do something awesome? Is there something you know you want to do? So the first way is to think, I want to be able to do this, and your purpose then is to take one small step in that direction. It's to get better in a way that, in the end, after a while, has you doing that thing you want to be able to do. Do you want to be an excellent object-oriented designer like Sandy Metz? Do a little exercise about object-oriented design. Are you amazed by people who build little prototypes out of NoSQL data stores to show how they do what they do? Great. It turns out that is a thing that you can move toward. You can absolutely do that. Method 2. What decision scares you? If you're trying to get better at programming, there's something you can't already do. Otherwise, why do you want to get better? So, there's some decision out there that you don't feel like you can already do. There's something you don't think you can build yet. There's something you don't think where you can choose the right technology. There's something where you're not sure how to build out the API. And so, if there's something you want to do that you can't do yet, great, lean into that. That's how you get better. That's where you get better. That's your purpose in getting better, is to learn how to do that. If you're afraid of functional programming, go out and try some. If you want to know more about Redis, and you're not sure if it's the right tool for using in your application, again, try it. So those two are fairly straightforward. What do I want to do? What am I sad because I can't do? Those are fine methods. Method 3. What's the weirdest thing that might possibly work? If you choose purposes that will make you good like other people, you'll learn things other people know how to do. If you choose purposes that help you to get past something, you'll choose some. You'll get better at something that will help you. If you pick something random, you may get better at something nobody knows. One of my favorite examples of this is that Ruby on Rails is taking a web app and taking dry, don't repeat yourself, to what at the time was a ludicrous extreme, a ridiculous extreme, to the extent that they would just read the database schema out of the database and make classes and functions to mirror that. I know many folks working in enterprise Java that will still tell you how completely unreasonable that is, and what you got was Rails. Most of the time you won't get anything that good, but you can get really interesting things. Take something, some constraint and do something interesting. Write only functions with a prime number of characters, and comments don't count as characters. Avoid all loops and recursion completely. Do something with no iteration. Come up with something weird, and you can learn something nobody else knows. So that's my third recommendation for a way you could pick a purpose. This is all sounding kind of abstract and up in the air, so let's do an example. You can see a little animation there of a merry-go-round. It's a kind of toy that is common on playgrounds in the United States, and people, push the kids around. Well, it turns out a while back I was out with my kids in a park, and there was a merry-go-round. And I was watching the kids, and I'm used to watching behavior, because, again, that's what we do for a living, and I noticed the younger kids wanted the merry-go-round pushed faster than they can push, and the older kids wanted to push so fast that the younger kids couldn't hold on. So I wound up writing that up as a simple coding study, just a really quick one, later after I got home from the park. So, as an example, tool, simple Ruby, task, tiny simulation of kids on a merry-go-round, and my purpose was to play with that behavior, that little simulation, age, strength, pushing, to understand it better. And the time box at the time then was about an hour. So, when you're just exploring something, the first thing you do is to make your code simple, and to make it work. So in this case, I was playing with the ages, and I wanted these things to be, roughly based on the ages. That list of ages there is about the ages of the kids who were in the park when my kids were. It was about what I saw, instead of there being some perfect, canonical reason for it. And for each kid, I made a little structure. That's their age. How hard can they push? And I picked something, reasonable based on the age. How much do they weigh? Kids tend to get heavier fast and then slow, and so sure, square root-ish. That's right-ish. And how hard can they hold on? But I'm doing this with exploration. There's nothing magic about these things that I did, and in fact I played with them a little bit to get to this point, but I did something that looked a lot like this. You can randomize. I find that no randomization makes it easier to see what's going on. You could make it into a dedicated class. Again, I find that's a little bit slower if I'm just exploring. There's not a wrong way to do this, really. But then once I had those little structures, what do? Well, merry-go-round starts out stopped, speed is 0, and then I just assumed that there'd be pushing by all the kids who could push, however hard they could push. There's weight, which slows the pushing down, and there's the speed, which is how hard you push over how much the weight slows it down. And then I just print that out every time round. And at some point, the kids can't hang on anymore. In this case, I know it's always going to be the youngest kid who stops hanging on the soonest, because again, I'm not randomizing. I just assume that younger kids can't hold on as well. And if they can't hold on, then, well, as it says in the code, kids.pop. And so, that's interesting. That's a good start to it. And at the time, I was, starting to run low on time. I played with this a lot of ways, and I was trying to figure out a way to bring it to a halt. Now, I'd been reading Sandy Metz's 99 Bottles of Object-Oriented Programming, which is amazing, and I recommend it highly to everybody, but it means everything kind of looked like a song to me for a while afterwards. When you work through it, you find everything kind of looks like a song for a little while afterwards. And so I thought, oh, okay, I know what I can do. I can turn this into a little song. And so I do. Every time one of the kids falls off, I say, so many little monkeys on the merry-go-round. One falls off and bumped his head, and then eventually you run out of monkeys. Kids.popped until there's no more kids. So I wrapped it up and turned it into a little song. But again, remember, the time limit was coming to an end. I'd played with it, I'd learned some things, and I had a little time, so I chose to wrap it up. But you don't have to. If you run out of time, you run out of time. Study accomplished. So, I'm going to go over 7 guidelines for practice. You can use these with coding studies. You can use them in any other way you like. I think they're good guidelines. And since rules are never absolute, I'm going to tell you why I think you should do each of these. What happens if you break them? My first rule was choose first and write. You remember I told you to write down the tool, the task, the purpose, the time box. Write it down in words. And the reason I told you to do that is because when you are on a time limit and you're trying to figure out if you're doing the right thing, or even if you're not, you want to know, does this advance my goal? Does this do what I want to do? And to do that, you have to know what you wanted to do. So write it down. And if you break that, then you get feature creep. You can't tell if what you're building is exactly what you set out to build. So you tend to get an unfocused thing, and it tends to take a while. My second rule is that time limit. I keep saying the time box, time box, time box. That's probably unfamiliar to a lot of folks here. You probably don't work that way most of the time. I literally set a timer. I'll give you a link to a video where I do that afterwards. Choose the time limit. So if you break that, if you don't have a time limit, you'll tend to get long failures where it takes you a long time to get started, and instead of burning an hour or 3 hours on that, you can burn a day or a week on that. And so something where you have trouble just getting started will tend to eat a lot more of your time in a really bad way on those failures. But that's not the biggest reason to do it. The biggest reason is long successes, where you do what you want to do and you're feeling happy about that and you keep adding features to it because that feels good, but you've long since learned what you wanted to learn, and now you're just burning your time on it. And the successes are often more costly than the failures. Rule 3, throw it away. I know this is unexpected, and it's hard. It is hard. The thing is, if you plan to throw it away from the time you start, you are not going to spend a lot of time engineering this like production code. You're not, which is perfect. You want to learn the most from this. If you spend your time writing events and logging, if you spend your time writing extensive tests, if you spend your time doing anything to turn this code into a reliable, solid product like you would deliver on the job, you're wasting learning time. You are learning more slowly than you could be. If you know from before you start that you will be throwing this away, you're going to be a lot more daring in what you try. You're going to be a lot more willing to fail, and you're not going to build it to these solid requirements. If you want to build something like this out with solid requirements, great. Build a prototype first. What you are learning here are prototyping skills, which make you as good at learning as you can be, and then you can build the real thing afterwards. Number 4, one idea at a time. Your purpose is like a priority. It's the main thing you want to do. If you have a list of priorities and you put 3 of them at the top, what that means is you have no priority. There has to be a top priority for it to be a thing. And this, again, do you know what you're doing? If your purpose is one idea big, preferably about a sentence long, you look at it and you can say, yes, I'm doing it, or no, I'm not doing it. If it's a complicated mess with 3 or 4 ideas, and you look at it, you can say, well, maybe I'm doing it, which is no good. You want to instantly say, yes, I'm doing it, or no, I'm not doing it. One idea at once. Simple with layers. Build simply and in layers. You notice how I started with the debug statements on every time through the loop, and I put the little structures together in a simple way, and then I started, looping a little bit. I actually started with even smaller than that and built that out. You want to build with a tiny thing, as tiny as possible or tinier, to begin with, and then slowly build it out. This is true everywhere, but it's especially true when you're building out a prototype when you don't know what it's going to be yet. You don't want to have to do a huge amount of building to get to the point where you have something to play with. Debug statements are also great. Add lots of them, especially right at the beginning. You can always take them out, but the knowledge that you get from seeing a debug statement go off teaches you in a way that you wouldn't get if you didn't have them. If it's broken, you get a long startup time for each coding study. It takes you a long time to get to the point where you've got functionality, and you don't want that. You want this to be as rapid as possible. And you've got a dread of starting. If it's going to be a long build-up before you've got anything useful, you don't want to start as much. Whereas if you're going to very quickly have something fun to play with, you're going to get started. You want to do, Rule 6, work from life. This is the same as choosing a task in an interesting way. Look at a real system in the real world, like me going and looking at kids on a merry-go-round. By staring at real-world complexity and letting it surprise you, you are going to learn in a way that if you're just recycling ideas you already have in your own head, you'll never learn. And if you break this, you're only refining the ideas you already have. You're only refining what you already know. Your biggest cheat for learning is to go out, look at the world, and have it surprise you, because then you wind up knowing something that otherwise you would never have known. And rule 7 is break the rules. None of these rules are absolute. Nothing is set in stone here. Break rules when it makes sense, or break them just to see what happens. This is play. This is not work. You want this to feel good because you want to do a lot of it. I mean, you're talking about doing this as a lifestyle, right? If your practice is hard and nasty and feels bad, you will do a lot less of it. Do what you can to make this play. It's also fun to do what I call unbreaking rules. Take some rule and do it to such an extreme that it breaks all the other rules. Whether that's something like time boxes. Maybe you do shorter and shorter time boxes to find out how much code you can build in 30 minutes, and then 20 minutes, and then 10 minutes, and then 5 minutes, and then 3 minutes. You can't hold a lot of other rules while you're doing that. It turns out the time box rule is already going to tell you everything you need to know. But you take this rule and you stretch it as far as you can stretch it just to see what happens, just to see what it teaches you. Break rules. Maybe one at a time, maybe a few at once. Again, maybe unbreak one completely. All right, so when I tell you to work from life, that's a hard one. That's one we're mostly not used to doing. So let's talk about that a little more. There's never a shortage of complicated systems. The real world is so complicated you will never run out. So then the hard part is figuring out what you find interesting. The hard part is choosing what piece of complexity you're interested in. I like systems related to people, stores, walking patterns, group dynamics, individual behavior and how people think. The good thing about working from people is that people are complicated, and you, as a human being, have a really good idea how they act. That's why the Turing test is so hard, because people are really good at telling whether a particular thing is acting like a person or not. And that means when you write code that's about people, you are graded very hard, because you can tell really exactly whether it's right. And grading hard is the point. Again, you want reality to surprise you. You want to learn something new. And by grading yourself hard, you're more likely to learn something new. You're doing a hard task, and you're doing it in an interesting way. Go you. You can, of course, pick things that are not people. If you're trying to learn about recursion or self-similarity, a lot of the natural world, leaves, plants, seashells, are structured in a self-similar way. And so maybe what you want to do is to work on some structure of that. Maybe you draw a little picture of them. There's a lot of ways you can do it. If you want to learn about iteration, children's games or simple mechanics like rocks falling into water are often a good place to look, because that's sort of iterative in nature. It tends to boom, 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 boom. For modularity and encapsulation, I recommend looking at artificial systems, things like buildings or things made of people, because complete separation between two things is often a human phenomenon. The real world tends to have everything kind of blend into each other in nature. All right, for pairing on these, the short version is just do it. Make sure to pair on deciding the task, not just writing the task. But in general, if you want to do a coding study pairing with somebody, it works really well. Do it like any other sort of pairing. Do one person on the keyboard at once while the other person is helping design or watching or debugging. Same as always. Same as always. I said I would tell you who I stole this from, what profession I stole this from, and it turns out the other group that has far too many tools and has to learn through practice is artists. They've got very much the same set of problems that computer programmers have, and they use very much the same exercise. I've more renamed it than I have changed it. But they call it a life study. You've heard of still lifes, where they do a life study of objects, or there's figure drawing, where you do a life study of a human. Artists have to learn a small number of deep principles, things like color composition and edges, and where you put various objects and contrasts. And they learn it through using these tools. You can't just... Well, I mean, you can just study the principles, but the way you learn them in a useful way is to actually take a charcoal pencil or a paintbrush or something like that and actually do it. In the same way, we have deeper underlying principles, things like modularity, things like object-oriented design, that we have to learn through whatever language we're currently using. And we do it in the same way through studies of one kind or another. And so the practical study teaches you the abstract underlying skill, because there's no other way to really get them the way we need them. If you like this, if you think it's an interesting idea, where next? I'm going to post some links in the chat to further resources. Commercial warning, I do sell a book on this topic. All right, and we're going to move right into chat and Q&A. wonderful to talk to you, and I'm looking forward to doing it again very soon.